All right, Algebra 2, we're going to finish off the prerequisite chapter, part 1 here. So we're going to talk about absolute values and distance. And in general, remember, an absolute value is always going to be positive. Okay, what it really means is if I ask you for the distance from 5 to 0, well, you would say 5, right? Because from 0 to 5, that's 5 units. If I ask you from the distance for, 0 to negative 5, yes, I'm going down 5 units, but that's still a distance of 5. So no matter whether I'm looking from 0 to positive 5 or from 0 to negative 5, we take the absolute value of that distance to show that the distance is always going to be a positive value. All right, so if I'm looking for the absolute value of 2.6, that's just 2.6. This is going to be the negative 8, right? Because the absolute value of negative 8 becomes positive, and then I bring down the negative there, so the answer is negative 8. And here, this absolute value of 1/3 is just 1/3, and then again, we have to bring down the negative, so negative 1/3 is the answer there as well. This next is what we're going to do is we're going to evaluate this this function. So if you look at this function, it's actually, well, we'll call it an expression for now. All right. So if you look at this expression, absolute value of x minus 2 over x minus 2, if you were to graph this on Desmos, what you would notice is the graph is going to continue from negative infinity, and then it's going to hit a certain point, and then at that point it's going to jump up and continue to positive infinity from that new level there. Okay, that's what the graph is going to look like. And it turns out that when x is equal to positive 2, we get this jump. All right, now these are open dots here, and so there's actually no possible value when x is 2. Okay, the reason why that is because if I look at the denominator, we see the denominator is x minus 2. So what's happening is when I plug in a positive 2, when x equals 2, 2 minus 2 is 0, and it doesn't even matter what's going on the top. On the bottom of this fraction, if I divide by 0, I get an undefined answer. All right, so that's why this is all undefined at 2. Okay, so what I'm going to try to do is, we know that when x is 2, this is undefined. All right, but we want to know what happens when x is bigger than 2 and when x is smaller than 2. So if we look at what happens when x is bigger than 2, that's going to correspond to all this over here on the right side of the graph. Okay, so if I plug in a number bigger than 2, let's test out, you could test out 10, 11, 12. Let's test out 3, though. 3 is probably a little bit easier to work with. So if I plug in a 3, we get the absolute value of 3 minus 2 over 3 minus 2. And this numerator is just 1. The denominator is also 1. So our answer is going to be 1. So that means that when x is bigger than 2, no matter what, even if we try to 5, right? If we try to 5, we would do absolute value of 5 minus 2 over 5 minus 2. This is 3 over 3, which is still 1, right? So it doesn't matter what number you test. As long as it's bigger than 2, you're going to get an answer of 1. And that's why this is all at positive 1 here, right? So this would be, 3 comma 1. This would be 4 comma 1. This would be 5 comma 1, right? You get the idea. If x is less than 2, well, we can test out a number that's less than 2. Let's try out, how about 0? That's an easy one. So we're going to test out 0. So we're going to plug in 0 minus 2 over 0 minus 2. And so we're going to end up with the absolute value of negative 2, which is just 2. All right, so this is actually come out to be negative 1. So that means that at this level down here, we're at negative 1, right? So you get the idea, 1 comma negative 1. This would be 0 comma negative 1. This would be negative 1, right? And the idea is the same, all right? So those are the different values when x is 2, when x is greater than 2, or when x is less than 2. But the key place to start is look at your denominator, right? Think about what would x have to be to make the denominator equal to 0. Next up, we're just going to place the appropriate symbols, all right? So I'll give you a sec to pause the video and try that on your own. All right, and the answers are up there. Now, if I'm finding the distance between 2 points, and this is something that you maybe want to write in the notes down here, the distance between 2 points is the absolute value of the difference. All right, so what that means is all I have to do is take the absolute value and then subtract the numbers in between, right? So I'm going to subtract, I've got this negative 24 minus 78. So this is going to be the absolute value of negative 102, which is just 102. All right. Now, it actually doesn't matter the order which you put these numbers, right? Let's say I do this again. I'm going to take the absolute value of the difference. But what if I start with the 78? Well, if I start with the 78 and then I put in the negative 24, I have a double negative here, right? So if I've got this double negative happening, that's really a plus. So 78 plus 24 is 102, and the absolute value of 102 is also 102, right? So it doesn't matter which way you organize these numbers. The important thing is that you subtract them in either order, subtract them, and then take the absolute value. So let's try this next word problem. All right, at 2 p.m. the temperature was 25, but then it dropped to negative 19. So I'm going to take the absolute value of the difference. I'm going to do 25 minus a negative 19. So that's a double negative, so it becomes positive. So this is like the absolute value of 44, which is just 44 degrees. All right, so the difference in temperature is 44 degrees. Next page with algebraic expressions. Which of the following is an example of an algebraic expression? I'll let you try to circle as many as you think are algebraic expressions. But the answer is all of them. And if you think about what algebra means, algebra involves variables, right? So all of them, because they all have variables. All right. If you had something like 5 is an expression, but this would actually be a numerical expression. All right, because there's no variables. Okay, so a numerical expression is just with numbers and operations. An algebraic expression has to have variables and operations. All right, so next, in these algebraic expressions, identify the terms and the coefficients. All right, the terms are each thing separated by a plus or a minus sign. All right, so we have 3 terms in the first one, and we have 1, 2, 3 in the second one. All right, so those are my terms. All right, so in the first one, we've got 3x squared, we've got a negative 8x, don't forget that minus sign, and we've got a positive 1. In the second one, we've got 5 over c, we've got a positive 1/4 b cubed, and we have a negative m. All right, now if I'm looking for the variable coefficients, right, not just the coefficients, but the variable coefficients, I'm looking for all the numbers in front of the variables. All right, so if I look carefully, I can see that we've got a positive 3, right? 3 is in front of the x squared. And we've got a negative 8, because negative 8 is in front of the x. And then the 1 doesn't have a variable with it, so we're going to not have to worry about that one. In the next one, we do have a 5, right? It's like 5 times 1 over c, so 5 would be a variable coefficient. We've got the 1/4, that's in front of b cubed. And then we can't really see it, but we have to infer that there is a negative 1 in front of the m. So those would be the variable coefficients. All right, next up, we're going to evaluate some expressions. So we're just going to plug in some numbers, right? So when x is negative 3, we're just going to plug that right in. So negative 2 times negative 3 plus 11. This is 6 plus 11, which is 17. Then I'm going to take this v equals 5 and plug it in. Now remember the difference, right? If I had negative 5 squared, this would be negative 5 times negative 5, which is positive. But if I have negative 5 squared, I have to do exponents first, right? That's order of operations. So this would be like negative 25, all right? And this is the situation we have to work with this time, right? When I plug in that 5, that gives me a negative 5 squared over 8 plus 1/3. And that's going to be equal to negative 25 over 8 plus 1/3. I do want to get like denominator, so I'm going to multiply to try to get these to become 24. That's the LCD. So 8 over 8 here and 3 over 3 here. All right, so now we've got negative 75 over 24 plus 8 over 24, and that's going to leave us with negative 67 over 24. And there you go. All right, the last parts, all right, basic rules of algebra. These are rules that we've talked a lot about before. We haven't always cared so much about the names necessarily, but we actually use these properties quite a bit, and we do this when we do calculations all the time, all right? So I put down all the examples here, all right? I want you to pause the video and write down these examples. And as you're writing down the examples, think about what you could write for these examples using just algebra, okay? So algebra, again, is just letters. You can obviously use plus, times, multiply, divide, equal symbols as well. Parentheses are great. But try to think about it. So I'll do the first one with you. But what this example shows me is that I can add in this order, or I can flip it around and add in that order. So it's basically saying it doesn't matter the order in which I add things. I can add them in any way I want. So let's try to use the letters A, B, and or C in this column. And so what I can say for the commutative property of addition is that A plus B is going to equal B plus A. Right? Doesn't matter the order you add them. So for the commutative property, I like to think of these as being associated with order. And for the associative property, I like to think of these as changing the grouping. Okay, so that's what I like to think of those as. All right, now the commutative property of multiplication has only multiplication. By the way, if you haven't paused the video, you have to try the rest of these algebra columns. Make sure you do that. So the commutative property is going to be A times B equals B times A. Again, you can multiply in any order, right? 5 times 2 is the same as 2 times 5, both equal to 10. The associative property of addition tells me that it doesn't matter how I group numbers together. All right, notice I'm not changing the order at all, right? It's still A, B, C, A, B, C. But the order that I've grouped them is a little bit different, okay? Same thing with multiplication. I can do A times B times C, or I could do A times the quantity B times C. So I can choose to multiply A and B first and then times C, or I could choose to multiply B and C first and then times A. It's not going to make a difference at all. All right, distributive properties, kind of two ways to think about this. If I take A times the quantity B plus C, this A would be distributed to both parts. All right, notice how the distributive property has multiplication and addition. The other properties that we've talked about so far are either all addition or all multiplication. So this would be AB plus AC. Even if I had the letter A at the end, it doesn't matter. I would still multiply that A times both pieces. So it would still be AB plus AC. All right. The additive identity property just says that if I take a number and add 0 to it, I get the same number. It keeps its identity. For multiplication, I would have to multiply that by 1 for it to keep its identity. The additive inverse, well, the opposite of adding is subtracting. All right. And for the multiplicative inverse, the opposite of multiplying is going to be multiplying by the reciprocal. All right. We have a lot of negation properties. All right. This first one is just saying, hey, if I multiply a number by -1, I get the opposite of that number. The second one is if I have the opposite of a negative, I get a positive. The next one is saying, hey, it doesn't actually matter if I have a negative times a positive, or that positive times a negative. It's still going to be the same either way. So it doesn't matter where you put that negative symbol. As long as there's a negative in there, the answer is going to be negative. Next up, when I multiply two negatives together, I get a positive. So negative A times negative B is going to be positive AB. And then the last one, if I have a negative out in front of a set of parentheses, I'm basically distributing that negative to each piece. So the negative applies to the A, and the negative applies to the B. All right. The last four we know very well. These are the addition properties of equality, subtraction, multiplication, and division properties. All right. So it basically says if I take any number, I'm just going to quick kind of start these off because I have to use the same marker color for all of them. All right. Let's use blue here. So if I add a number to both sides, that does not change the equation. If I subtract a number on both sides, same thing. I'm allowed to multiply the same value on both sides, and I'm allowed to, I don't know why I chose C there. You could choose B, that's fine. Sorry, I don't know why I chose C, it doesn't really matter. Or you could divide the same thing on both sides. All right, so those are the different properties. Now you have some actual names to the things that you've been doing. So this is a great page to just take a look at